Hi students, as a part of electrochemistry, today I am going to explain you about the Nernst equation. So before going to see what exactly is the Nernst equation and its derivation, first let us see what is the importance of the Nernst equation. The equation which is used to calculate the electrode potential of the electrode is called as Nernst equation. Mathematically, it can be expressed as E equals to E naught minus 0.059 by N log C, where E is the electrode potential of the electrode, E naught is the standard electrode potential of the electrode, and N is the number of electrons involved in redox reaction, and C is the concentration of an electrolyte. So now let us see how this particular Nernst equation can be derived. So let us see how this E equals to E naught minus 0.059 by N log C can be derived. So during the derivation of any of the expression, whether it is the mathematical expression or physical expression or chemical expression, whatever the expression is, so definitely you have to keep the final equation in your mind. So accordingly you have to derive, but don't derive it vaguely. So if you go vaguely, then you cannot catch hold of that particular chain by which we can get the final equation. So don't go vague manner. So you have to catch the chain and you have to go accordingly in order to get the final equation. Right. Now our target is E equals to E naught minus 0.059 by N log C. Keep this in the mind. Now let us recap the electrochemical cell, because there is a relationship between electrochemical cell and the derivation of Nernst equation. So what is electrochemical cell? The cell which makes use of spontaneous redox reaction and convert the chemical energy into electrical energy. In fact, during the spontaneous redox reaction between the two electrodes which are a part of the electrochemical cell, some amount of free energy is released. That free energy which is released during the spontaneous redox reaction between the two electrodes which are a part of electrochemical cell is being converted into electrical energy. To be more precise, the free energy which is being released during the spontaneous redox reaction between the two electrodes of the electrochemical cell is Gibbs free energy. That Gibbs free energy is being converted into electrical energy. Now that Gibbs free energy can be represented as minus delta G. Why minus sign? Because there is a loss of energy. What is happening during the spontaneous redox reaction between the two electrodes which are a part of electrochemical cell? Free energy is being lost. So in order to represent that loss of free energy, minus sign is given for this delta G. And that free energy in the form of chemical energy is converting into electrical energy. That electrical energy which is going to be produced during the spontaneous redox reaction between the two electrodes which are a part of the electrochemical cell, let us say it as NFE of cell. NFE of cell. What is NFE of cell? Electrical energy, that is which is being produced. Now, both these values can be equated. Why? Because how much amount of Gibbs free energy is being released during the spontaneous redox reaction between the two electrodes which are a part of electrochemical cell is being converted into electrical energy. So that much amount of Gibbs free energy is converted into electrical energy. So the free energy, that is Gibbs free energy, can be equated with the electrical energy, where NFE of cell is nothing but the electrical energy, right? where N is the number of electrons involved in redox reaction, F is Faraday, which is 96,500 coulombs, and E cell is nothing but EMF of the cell. EMF of the cell. Let us consider this as equation number 1. Equation number 1. Now this equation number 1 can be written in this fashion also. What I am doing is, whatever the minus value which is there on left side, I am bringing it to right side. So just I am changing the position of this minus sign. The remaining is 1 and C. So let us say that this is the equation number 2. Right. Now let us say that whatever the substances which are involved in the electrochemical cell all are at standard states. That is the concentration of electrolyte is fixed at 1 molar, and the length of the electrode is fixed at 1 centimeter, and the temperature at which this electrochemical cell is functioning is 25 degrees centigrade. When the standard conditions are being maintained during the spontaneous redox reaction between the two electrodes which are a part of electrochemical cell, then this equation number 2 can be written as. That is, first let us see with respect to 1. So that is minus del G naught becomes equals to NF E naught of cell. This is equation number 3. Right? Now this can be written in this fashion. The same thing, what I am doing is, whatever the negative value which is there on left side, I am bringing it to the right side. The remaining is 1 and C. Let us assume this as equation number 4. Where del G naught is standard Gibbs free energy and there is no change in N. N is the number of electrons involved in redox reaction. F is Faraday 96,500 coulombs, and E naught of cell is a standard EMF of the cell. Now you would be in a dilemma that what would be the next step. So what would be the next step, students? We have the two values. That is, we have the del G and del G naught. Now the next step would be the equation which relates this del G and del G naught. So in this fashion you have to remember but don't memorize. So what would be the next step? The next step would be the equation which can relate the del G and del G naught, because the del G and del G naught are the previous equations. So the next equation will be the equation which can relate the del G and del G naught. So that equation which relates the del G and del G naught is del G is equals to del G naught plus RT ln K aqueous. So let us assume this as equation number 5. Now what would be the next step? There is no need to memorize the next step. So we have the del G, right? Already it is there, and del G naught is there, and R is constant and T is constant. We don't know what is equilibrium, that is K aqueous. Now the next step would be our K aqueous. That is, what is K aqueous? So K aqueous is nothing but equilibrium constant, students. K aqueous is nothing but equilibrium constant. Now what is equilibrium constant? It is the ratio of concentration of the products to the concentration of the reactant. So K aqueous is the ratio of concentration of the products to the concentration of the reactants. Let us assume that this as equation number 6. Now, what would be the next step? What would be the next step? Don't be in a dilemma. What would be the next step? Next step is the equation, or the next step is something which comprise the product and reactants. What is the next step? The something which comprise the products and the reactants. Now, what is that something which comprise the reactants and the products? That something which comprise the reactants and product is the chemical reaction. Chemical reaction. Now we have two chemical reactions: oxidation reaction and reduction reaction. Now don't be in a dilemma that whether we have to consider the oxidation reaction and the reduction. Right. So which reactions are there in the literature? Which reactions are there in the literature? So if you see the electrochemical series, in the electrochemical series, you will find the standard reduction potential values, and those values were obtained by considering the reduction reaction. So reduction reactions are there in the literature. So accordingly, in order to get the information about the product and the reactants, in turn to get the information about equilibrium constant, we have to consider the reduction reaction. Now, what is that reduction reaction? So consider a solid gaining n electrons, giving rise to A minus N aqueous. A minus N aqueous. So this is the reduction reaction. Next, what is our target, student? Why we have considered this reduction reaction? Why we have considered this chemical reaction? In order to get the information about the equilibrium constant. So now, accordingly, what is equilibrium constant? Equilibrium constant for this particular chemical reaction is concentration of the product. What is the product here? A minus N. Concentration of the product by concentration of the reactant. What is the reactant here? A solid. Concentration. Right. Now, do remember, students, that during the functioning of electrochemical cell, neither the liquid moves nor the solid moves. Only the movement of ions will take place. So, only we have to consider the movement of ions, and the remaining values should be considered as unity. Their value should be considered as 1. Accordingly, so A solid, so it is not moving, so its value should be considered as 1. So the leftover part, but this value cannot be considered as 1 because it is the ion, and the ionic movement will be there during the functioning of electrochemical cell. So accordingly, K aqueous equals to A minus N concentration aqueous. Right. So now, let us say that this is equation number 7. Now substitute this equation number 7 in 5. Substitute equation number 7 in 5. So what is that? 5 del G equals to del G naught plus RT ln K aqueous. So what is K aqueous? Equilibrium constant, concentration of A minus N aqueous. So let us assume this as equation number 8. Right. Now, what is our final equation, student? E equals to E naught minus 0.059 by N log C. But here the equation is in terms of del G and del G naught. So now what we have to do? We have to get the values of E and E naught with the help of this equation number 8, because we know that del G is minus NFE of cell and del G naught is minus NFE naught of cell. So our next step would be getting the values of minus NFE and minus NFE naught, because the final equation contains E and E naught, but it won't contain del G and del G naught. So now what we now to do? Substitute equation number 2 and 4 in equation number 8. So substitute 2 and 4 in equation number 8. So what is 2? Del J is minus NFE of cell equals to, what is del G naught? Minus NFE naught of cell plus RT ln K aqueous. And K aqueous is nothing but A minus N concentration. So whether it is A minus N or B minus N, whatever it is, students, it is the concentration term. So since it is the concentration term, instead of writing A minus N concentration, just I will write as C, because it is a concentration term. Let us assume this as equation number 9. So in our final equation, A is equals to E naught minus 0.059 by N log C, we don't have NF. We have E equals to E naught minus 0.059 by N log C. So what we have to do in order to remove the NF, we have to divide on both sides with the NF. And we don't have minus E and minus E naught. So what we have to do? We have to remove this minus value. So what we have to do? With this 9th equation, we have to multiply on both sides with minus, and we have to divide on both sides with NF. So multiply on both sides with minus and divide on both sides with the NF. So minus into minus, it becomes plus. So NFE cell by NF. So NF cancel. So the remaining portion is E cell equals to minus into minus plus NF by NF gets cancelled. So there will be only E naught cell. Next, minus into plus, minus RT by NF is there, students. RT by NF ln C. Consider this as the equation number 10. Now this is ln C, students. Ln C means log base E. Now we have to convert this log base E to log base 10. In order to convert the log base E to log base 10, we have to multiply the portion of the equation which is associated with the ln. We should not multiply the whole equation with 2.303. We have to multiply only the portion of the equation which is associated with ln. So what is that portion of the equation which is associated with ln, students? Only this portion. So we have to multiply. So E cell equals to E naught cell minus, this is the portion of the equation which is associated with ln. So in order to convert the ln, that is log base E to log base 10, we have to multiply with 2.303. So 2.303 RT by NF. Now log base E, that is ln, becomes log base 10 log C. So almost we got the equation, student. What we need to do? So E is equals to E naught minus 0.059 by N log C. But we have R and T. So R value is standard. That is, R is universal gas constant. Its value is 8.314 joule Kelvin inverse mole inverse. And F is 96,500 coulombs, and we have T is temperature on absolute scale, that is 273 Kelvin. Now substitute all these values in equation number 11. So finally we will get E equals to E naught minus 0.059 by n log C. So in this fashion you have to remember what is the next step, but don't memorize the next step, because there will be a link between the next and the previous step. Try to catch hold of that link. So if you catch hold that particular link, then it is very easy to derive any of the equation, whether it is mathematical, physical or chemical. I hope you understood this, students. And this Nernst equation is especially used to calculate the electrode potential of the electrode. Apart from that, we can also determine the concentration of the ion present in the solution by rearranging this equation. Not only that, this Nernst equation is used in conductometric titrations and potentiometric titrations. I hope you understood this Nernst equation, students. Thanks for watching.